2015 Projectiles question 3 part A. This is my attempt at drawing a tennis court. Just a diagram that was given to you in the question. We're told that a tennis player stands at P, serves the ball from a height of 3 meters to hit the court at Q, and the speed of the serve is 50 meters per second, and it's at an angle beta to the horizontal. Find two possible values of tan beta. Well, if we create a better diagram, so look here. So here's the height 3 meters. He's serving it from here, obviously jumping up and hitting the ball, and it's going to hit the court. It's at an angle beta to the horizontal, so it's an angle up this way, and we are told that it hits the court at point Q, so it's going to come down here to Q, and the distance we can see here, we were given this 6.5 and this 12, so 18.5 is the distance. This is Q, this is P, and the speed was 50. So if I write down my initial velocities, it's going to be U. We have the U is 50, and the angle is beta, so 50 cos beta in the I direction, plus 50 sine beta in the J direction. We have the distance in the I direction, so the distance in the I direction is just UT, S in the I direction, no acceleration, so UT. So that's equal to 18.5, so this will help me get the time it takes to get to Q. So 50 cos beta by T is equal to 18.5. So the time taken to get there is going to be 18.5 over 50 cos beta. Then the distance traveled in the J direction will be a minus 3 in this case. So if we set up our J with UT plus a half AT squared, we're going to get 50 sine beta by the time, which is 18.5 over 50 cos beta. Acceleration G, so minus G over 2 by my time to be squared. So that's going to be equal to minus 3. So simplifying this out, we have a sine over a cos, so that's tan, and the 50s cancel here, so we're going to have 18.5 tan beta, and we're going to use the quadratic here, so we're going to take 9.8 as G, so 9.8 over 2 by 18.5 squared will be on top and divided by 50 on the bottom, gives 0.67081, so minus 0.67. That's all my numbers, and I have a cos squared beta, which I'm going to have to change into tan now, and then plus 3 equals 0. So your 1 over cos squared, we've done this before in a previous video, so cos squared beta plus sine squared beta is equal to 1. We want 1 over cos squared, so there's my 1 over cos squared. So divide everything by cos squared beta, and we're going to get 1 plus tan squared beta is equal to 1 over cos squared beta. So we're going to end up with 18.5 tan beta minus 0.67 over tan squared beta plus 3 is equal to 0. Sorry, I should have put that's 1 plus tan squared. I'll leave that as cos squared. We've worked it out to be, what have we worked it out to be? 1 plus tan squared. Sorry. So we've got 18.5 tan beta minus 0.67 by 1 plus tan squared beta. Just be careful rearranging these. Plus 3 is equal to 0. 18.5 tan beta minus 0.67 minus 0.67 tan squared beta plus 3 equals naught. So we're going to need to make this positive. So we've got 0.67 tan squared beta. And we have plus 18.5 tan beta, which is going to turn into a minus because we changed the sign of that one. So minus 18.5 tan beta. And we're going to have a plus 3 minus 2.33. So it's going to be minus 2.33 equals naught. Now you could say let tan beta equal x and just do it that way, or you can just identify this as a quadratic. So if we solve this, we are going to get, for our solutions, which will be tan beta, get used to using the quadratic formula on your calculator. Tan beta is minus 0.1254. And the other solution that it gives me, 27.7373. So if I change them into angles, my angles will be minus the angle 7.14 degrees. This one gives me 87.9 degrees. Part 2 asks the time taken. So just what was our time? 18.5 over 50 cos beta. 18.5 over 50 cos beta. So 18.5 over 50 by the cos of minus 7.14. That on a calculator is going to give me a time of 0.373. The second one is going to be 18.5 over 50 cos 87.9, and that gives me a time of 10.1 seconds. It doesn't seem very realistic for a tennis serve, so this definitely looks like the more realistic value. Part 3 asks if the player chooses the smaller value of t, by what distance does the ball clear the net? Okay, the diagram might help here. Here's P. He's 3 above the ground. The net is 1 above the ground. So 1 on this side. And the distance that the net is away from P is this 12. So this is 12 along here. So we're imagining that the ball is going to clear the net, so it's going to travel 12 in the I direction. So we can work out the time taken to travel this distance here in the I direction. So the time taken was, well, it was 18.5 because this was the distance, the total distance. So this value 12 will replace the 18.5 over 50 by the cos of minus 7.14. That will give me 12 divided by 50 times the cos of minus 7.4, 0.242 seconds. Now what I need to do is I need to get this distance from here to here in the j direction, and the distance in the j direction, or the displacement in the j direction, ut plus a half at squared. Just double check your u. My initial u, of course, it's 50 sine beta. So 50 sine minus 7.14 times t, which you just worked out to be minus 0.242. And I can go straight to minus 4.9 here. G over 2 minus 4.9 by 0.242 to be squared. So this is going to give me, we can see it's going to give me minus 1.79. So it's gone down minus 1.79 meters. This distance on this side from here to here was 2 because the height of the net is 1. So we're going to have to say 2 take away 1.79 meters is equal to 0.21 meters or 21 centimeters.